ఓకేనా సార్?
డన్ సార్, బాగుంది.
కంప్లీట్ స్క్రీన్ వస్తుంది కదా?
కంప్లీట్ స్క్రీన్ అంటే మాకు వస్తుంది, అదేలేండి వచ్చేసింది. కార్తిక్ పిన్ టు స్క్రీన్ డన్. ఓకే, స్ట్రీమింగ్ స్టార్ట్ చేయి. స్ట్రీమింగ్ కూడా వచ్చేసి ఓకే, రైట్.
ఓకేనండి. అయితే
ఓకే సార్, వస్తుంది సార్, ఏమి ఇబ్బంది లేదు.
ఓకే, నేను జస్ట్ స్టాప్ చేస్తాను, మళ్ళీ విల్ మీట్.
ఓకే సార్, ఓకే.
ఓకే ఓకే ఓకే, వస్తాను.
ఓకే. చెప్పండి.
రాజు సార్,
సార్,
అదే అక్కడ అయిపోయిందా ప్రోగ్రాము?
అది ఇంకా రన్ అవుతున్నా సార్. ఒక్క నిమిషం సార్, ప్రోగ్రామ్ అయిపోయిందా, ఇంకా అవుతుందా? అవుతుందండి సార్.
ఓకేనండి, ఓకేనండి.
చెక్ చేసుకున్నాను. ఉండండి జాయిన్ అయిపోతుంది. హలో సార్ అమృత్ సార్
సార్ చెప్పండి.
సార్ ఎన్ని స్టార్ట్ అంటే లింక్ వాళ్ళకి షేర్ చేసేది
అదే వాళ్ళు చేయండి సార్.
అవుతుంది సార్ ఇంకా అవుతుంది
అవును అవుతుంది.
సర్లేండి అది తర్వాత వాళ్ళకి వేరే ఫీడ్బ్యాక్స్ ఇవ్వాలండి.
Including the RCC, the head of RCC, Dr. Ramesh Chandra and team, IIIC, the Industry Institute Interaction Cell, Professor E. Venkatramana, and more importantly, the ED cell, the Entrepreneurship Development Cell, Chief Coordinator being Mr. Kodandram and Coordinator Dr. SPSS Srinivas Raju, and the Institute
సార్ అంజద్ సార్,
సార్ చెప్పండి.
సెషన్ డన్. మనం స్టార్ట్ చేద్దామా? లింక్ పోస్ట్ చేద్దాం వాళ్ళకి, స్టూడెంట్స్ కి.
షూర్ షూర్.
షూర్. సరే సార్, నేను చేసేస్తున్నాను. నేను ఓకే చెప్పినప్పుడు చూద్దాం. స్ట్రీమింగ్ పెట్టావా? లేదు. అంజద్ సార్,
సార్ చెప్పండి.
యూ కెన్ స్టార్ట్ సార్.
ఓకే
Sir?
చెప్పండి మేడం.
Yeah. Shall we begin, sir?
ఎస్ మేడం. ఏమన్నా డైరెక్ట్ స్టార్ట్ చేయొచ్చా మేడం? ఏమన్నా?
Yeah, I will introduce, sir, then after you can start.
యా
మేడం 2 minutes. 2 minutes. ఒక 2 minutes. సార్ ఒక 2 minutes. ఒక 2 minutes ఇంకా స్టూడెంట్స్ జాయిన్ అవ్వాలి.
ఓకే.
Shall we proceed, sir? On this, sir?
Yeah, shall we start, sir?
Okay, okay, you can introduce.
Good afternoon, everyone. I'm Gautami Koduri, Assistant Professor, Automobile Engineering Department. Now I would like to introduce our speaker to this session, Dr. Sheikh Amjad, Professor, Department of Automobile Engineering, VNR VJIT. We welcome you, sir. Dr. Sheikh Amjad graduated in Mechanical Engineering from University College of Engineering, Osmania University, Hyderabad, and completed post-graduation in Automobile Engineering from Madras Institute of Technology, Anna University, Chennai. Obtained doctoral degree in electric and hybrid electric vehicles from PSG College of Technology, Anna University, Coimbatore. He has more than 20 years teaching and research experience. And to his credit, Dr. Amjad sir has 18 international and 1 national publications and presented 17 technical papers in international and national conferences. And he also delivered guest lectures, invited talks at various chapters and engineering colleges. Being a peer reviewer for Anna University, PhD and MS thesis, and also several international journals, and also an examiner and question paper setter for JNTU Hyderabad. Likewise, there are many accomplishments in his account. However, in due course, you will be knowing about them. So without any further delay, I request sir to begin the session. Thank you.
Thank you, madam, for the nice introduction. Yeah. So I will share the screen. Yeah, just a minute. Yes. Can you able to see this my screen? Sir, Raju sir, can you see the screen?
Yes, sir. Yes, sir. Yes.
Okay. I think some delay is there in the. Okay. Okay, let us start. So, good afternoon, everyone present in the session. So, I would like to give some brief introduction about the course curriculum and some interesting statistics about the automobile scenario in India as well as in abroad also. So, is the voice is clear, sir? Some disturbance is coming, I hope. So, at the outset, I would like to give some introduction about our program, automobile engineering program. So, what is automobile engineering and what we are going to study in this program overall? And this is okay. Automobile engineering branch deals with the designing, manufacturing, and operating of vehicles which are propelling on the roads. So basically, we call automobile is nothing but a vehicle propelling on the road. So we are going to design that vehicle, manufacture and test that vehicle, and finally we are going to operate that vehicle on road. And based on that latest technology, we are going to learn different technologies along with that. So this is one of the most challenging careers in the field of engineering, with covering different branches of engineering, like mechanical engineering we are studying here, electrical engineering we are studying here, electronics engineering, software, instrumentation, safety engineering. So these are the different other branches of engineering also we are covering in this program basically. So you have the broad knowledge of different engineering. So you will be, after completion of this program, you will be having some multidisciplinary kind of approach towards that engineering. Not only the automobiling, along with the automobile engineering, you will be having some kind of multidisciplinary approach, and you will be exposed to all the fields of engineering basically. So finally, this overall, this branch deals with the designing, developing, manufacturing, testing, servicing of the automobiles. So you will be having the career in the different fields of automobile. So based on the design, based on the manufacturing, production, testing, so servicing of automobiles, even some kind of insurance things like this, different variety of jobs you will be, job profile will be there. So before that, we'll have some simple scenario how the automobile industry in India compared to the world order things, and what are the different places we have these automotive companies in India. These things we'll discuss. So as you, most of the people, generally Detroit is a hub for the automotive. Suppose if you come to the India, generally Chennai, we can call it as a Detroit of India, basically. So because most of the major companies are now settled in majorly in Chennai. So not only in Chennai, other than the Chennai, we have the in the north side, in the near like Delhi also we have the so many companies, Gorgaon, and even in the west side we have some companies. In the east we have some Hindustan Motors and something. Even in the Maharashtra, Pune, we have the so many companies actually. So these are the overall picture of different companies location in the India. So most of the world manufacturing companies, major automotive companies are in India, and they're coming to India, and they're investing a lot, so that we'll be having a good opportunity and good employability also. So Indian automotive is the second largest and fastest growing sector in the world. Automotive industry is the second largest and fastest. So as per the GDP, it is contributing approximately 7%, automotive industry. So more than 50 manufacturers produce vehicles in India. More than 50 manufacturers, automotive manufacturers produce a vehicle, and more than 1,000 major component manufacturers. So 50 is nothing but manufacturer, like bike, car, or heavy vehicles, buses, like that, manufacturers of vehicle. So in 1,000 manufacturers of vehicle, other than that vehicle, like they are supporting to that vehicle, like suppose somebody will manufacture the piston, somebody will manufacture brakes, somebody will manufacture some other accessories to that major companies they will be supporting. And to supportingly, near more than 10,000 minor manufacturers are supporting these industries. So overall, if you see, we have very good vast industry depending, and employability is also very high. And if we come to the statistics of Indian auto industry, if you see, so we are the largest three-wheeler market in the world. So and second largest in the two-wheeler manufacturer after China, basically, and third largest in the small car manufacturer, and fourth largest in the tractor manufacturing, and fifth largest in the commercial vehicle. So this is the one top 5 ranking of our Indian vehicle manufacturing scenario. We can observe based on this how many. So what is the status of Indian automotive industry at present? So after 1991, after global this thing industrialization, so it has changed a lot. So earlier it was only very few companies were there. Now it scenario is completely different. So as per the 2000 last year statistics, if you see, so almost 92 million vehicles are produced worldwide, out of which 30 million vehicles are produced in India. That is the thing. So nearly 1/3 of vehicle are manufactured in the India. This is the latest statistics. So we can see how that growing trend happening in the India. Because so I will tell why it is happening and all these things. There are so many reasons. We'll discuss anyhow. So it is also estimated that Indian automotive industry will grow up to 75.8 million by 2026. This is the trend. See, nearly more than twice, 2.5 times development if compared to the 2019. So next 6 years, the growth will be enormous actually. So like this, so now it is approximately, last year it is 30 million vehicles, means for the next 2026, it is estimated somewhere more than 75 million vehicles are going to be produced by Indian automotive sectors. So now we'll come to that. This is a brief about the Indian, what is automobile and what is the scenario of Indian automotive industry in India and all these things. So now we'll go to that actual content of the session. So I'm going to discuss about the course structure and some syllabus briefly about the syllabus. And regarding this, if you have any queries, definitely you can always welcome and we can discuss these queries. So first of all, we have this BTech program as per RN 19 regulation you are following. So as per that program, you have 160 credits. So you have to clear 160 credits. Means every course, what you call is subject basically. So here we engineering we call as a course. So every course is having some number of credits. Suppose the 3 credits are 4 credits. Suppose the laboratory courses are means it may be 1 credit. Like that, there will be some allocation of credits for each and every course. So in the first year, in your first semester, you are studying 20 credits, and second year 20, and overall in the first year 40 credits you have to clear. And the second year 42, third year 43, and final year you have 35 credits, somewhat lesser credits, so that you will be concentrating more on the projects, and we have the less number of subjects in the final year, and mostly that too you will be having the professional electives as well as open elective courses. So in a distribution wise, if you see, we have the different category of courses, like BSc means basic sciences course. So like basic sciences, in the basic sciences, you will be dealing with the physics, chemistry, mathematics. These are the courses you will be studying. So whatever the courses you have studied in your up to this one, +2 or intermediate, senior inter. So the basics, whatever you have studied, next to level of engineering applications wise, you are going to study in the first year basically. So engineering sciences related to the something like other engineering courses which are helping the basic our automobile engineering. So common, these engineering courses will be common for most of the courses, like C programming will be there, some Python programming will be there, some engineering graphics, engineering, okay, using the AutoCAD, or some related courses. Basic engineering courses will be covering. So engineering sciences. So the contribution, if you see, basic sciences will be 11%, engineering sciences will be 13%, humanities and management courses will be around 5%, where we have some kind of English management courses related courses you are going to study. And PCC is nothing but professional core. So here you are going to study more about the core courses, means automobile engineering related courses you are going to study. So automobile engineering as well as the concepts, whatever the courses are delivering related to the automobile, these are the courses you are going to study in the PCC, professional core courses. And professional electives, these are the electives. Generally electives will start from third year onwards. So in these professional courses, your percentage is around 11% contribution. So 11% of professional elective courses, and final, this one is an open elective course. Open elective course is around 8%. So open electives, I will tell when you go into the career structure, what is the role of, what is the exactly open electives, and what are the options we have in VNR, especially compared to other universities and other colleges, neighboring colleges, or even other university. How better we are, what is the best thing you can get from the open electives, and how can we choose the open elective? These things we'll discuss during the curriculum. And the 10% you are going to discuss about the project. Means in the final year and final year, basically, you are going to, as well as in the pre-final year also, you are going to do some kind of a project related things, project work. So for the project work, approximately 10% of credits. So mandatory courses are also there. Some mandatory courses are recommended by the AICTE. So these are the mandatory courses we'll discuss in the structure. So this is the distribution of the courses in the overall in our program. So out of 160, this is the distribution of different. Majorly, we are going to study professional core courses, 42%. Remaining courses are distributed like this: basic sciences, engineering sciences, humanities, open electives, professional course, projects, like that. So you have to clear 160 credits. That is, you have to remember from the beginning itself. So in the first year, you are going to, this is the correct structure. These are the subjects along with the course code and along with the credits, number of the classes, number of tutorial classes, you can see finally. So total credits is 20 in the first semester. So in the first semester, you are going to deal with the calculus for engineers, applied physics, programming through C, basic electrical and electronics engineering, applied physics laboratory, programming through C laboratory, basic electrical electronics, and engineering graphics, and design sensitization. So if you observe here, most of the subjects are accompanied by the laboratory courses. So here, as per R18 curriculum, if you observe, most of the courses, they'll be having some hands-on training parallelly with some laboratory courses. So whatever you are studying, you are going to apply in the laboratory. You are going to get hands-on training in the laboratory. There's the advantage. So that you can easily remember, you can easily apply that thing, whatever you are learning in the class, and you are going to apply in the laboratory, and you are going to test it, or you are going to feel it on hands. That is the one advantage. So overall, if you see calculus for engineers, whatever the basics you have studied in the +1, +2, these are we are going to continue with respect to the engineering applications. So physics also same. And only thing is, here you are studying introduction, basically programming through C. C is there, and parallelly you will have the lab also. So this is very important course, I can say, so that you will have the very good placements. If you are very thorough and very good in programming of C, you will be getting good placement. Not only in the software companies, even in the core companies also, nowadays they are looking at the soft skills, not only the technical or core knowledge. Along with the core knowledge, they are looking at the software skills also. So C language is the very basic language, and it's one of the middle level language, I can say. And this is a basic. Even if you are using whatever you are using a laptop, you are using even phone also, C language is a basic. So based on the C programming basics only, now even Android is also working, even the iPhone, the Mac, whatever the Apple devices are there, operating systems are working. Even your Windows operating system is also working on the C language. So it's a language which is basic for all remaining high-level languages, basically, like a Python, Kani, even whatever next level languages are there. Different languages are there at level, even C++, other things, even Java. So next high-level language, all these high-level C is the basic. So this you have to concentrate a lot in this C language, and in the beginning itself you should be very careful, and you have to practice in the laboratory along with the theory classes. So basic electrical electronics is the one thing which is the application to that whatever you have studied in the physics, basically. So we are going to study about the different basics of electrical and electronics engineering, and some basic machineries like DC machines, AC machines, some kind of even electronics related to the transistor. These are the things you are going to elaborately study with respect to the engineering application. So in physics, whatever electrical electronics you have studied in the +1, +2 level, we are going to continue that in the engineering. So first semester, these are the things. Engineering graphics, basically this is the language of engineers. We call engineering drawing is the language of engineering. So earlier people used to draw on the drawing boards. Nowadays you don't have that burden. Directly you can use the computer, laptops, and you have the AutoCAD packages there, or any, of course, other packages also there. In our college, for the first semester, we are using the AutoCAD software. So you can download that software, and you can practice, and you can model that whatever the components are there, engineering components, even we can design and model, and you can analyze also. We can using the AutoCAD. So these kind of basics you will be studying in the engineering graphics. So design sensitization is one of the typical, one of the important thing, how to design, what are the design parameters. Okay, these are the things we are going to learn in the first semester. So in the second semester, in the second semester, you are going to learn in the linear mass, continuity in the mass 2, like you can call. So linear algebra and advanced calculus, engineering chemistry. So first semester we have the physics, second semester we have the chemistry, parallelly chemistry laboratory. And English is there. So to improve the communication skills, English lab is also you will be having, and parallelly, so that you improve you can have the live sessions and practical sessions will be there in English, so that to improve the overall skills, communication skills, and data structures through C. So this is one of, again, without data structures, again C is also incomplete, I can say. So that whatever the programming you have doing with using the logics, that should be stored in the proper and structured way. So C through data structure, or data structures through C, you can say. So that simple example I will give. So already have MSET, you are qualified, you got some ranks. So based on the marks in the MSET, you will be allotted ranks. So, and these things, everything will be prepared in a program wise. So whatever the things are there, and whatever the allotment of rank based on the marks, and everything will be stored in a structured manner. So for this, they will be using the data structures, so that whatever the program or data is there, that should be stored in a structured way. So we have the different techniques like arrays and stacks, like that. Different techniques are there. So C along with the data structures is compulsory, otherwise it's incomplete. So in the second semester, we are going to study about the data structures. So this is one of the best example. Suppose you are you are going to the internet, and you are taking you are giving your data, so that you are getting immediately, you are getting some your details. What is the rank you got? How many marks you got? How each subject, how many marks? What is the overall ranking? Or categories wise, what is the ranking? These are the things are no. So everything will be stored in as a data form. So further data structures is compulsory. So C is the logic where we are doing the programming, and the data structures is also important for the storing and structured manner of storing the data and all these things. So for this, we have the data structures through C. Laboratory is there, you can practice, and workshop practice. This is the one thing. So basic, this is common for most of the engineering students. So that in this workshop practice, you are going to study about the different kind of engineering, basic engineering hands-on practices, like that carpentry things, like that will be some kind of mold fitting kind of things, welding. So common, even electrical kind of fittings, how they do the electrical fittings, and how the circuits will be, how to study the circuits, how the carpentry work will be done, how that fitting and welding work will be done. These are the basics you will be having the hands-on training in the workshop, which is the basic. As engineering, as engineer, you must have this kind of basic knowledge. Even if you have small kind of repairs at home, also you can able to deal. So this is the thing. So after the first year completion, you will be having some of fundamentals of engineering. So you will be learning about the mathematics, application wise, chemistry you finished, physics you finished, English, communications wise, and the C language and data structures. So basic engineering. So these are the things you are studying in the first year. So which is fundamental for this entry into the any engineering, of course, any engineering. These are the common subjects for most of the engineering branches. So all your first year friends, irrespective of the branch, they will be studying this kind of programs only. And engineering mechanics is one thing. Engineering mechanics I forgot, which is again one of the fundamental subject for the engineering. Even for mechanical engineering, even civil engineering people also will study, automobile engineering people also study. So this is also basically physics, next level to the physics. Of course, engineering is nothing but physics. Basically, we are going to categorize into different branches. Again in the branches, again we are going to study at a different levels of courses and all these things. So this is about the first year. In the second year, you are going to third semester. Basically, again we have one more math 3. So here we are going to study the partial differential equations and numerical methods, and mechanics of solids, thermodynamics, metallurgy and materials engineering, automotive chassis, parallelly automotive chassis laboratory, metallurgy and mechanics of solids laboratory, and Python. So here is also thing you can see here. So next to that, as I said, C is the middle level language. Next I can say Python is the high level language. So suppose if you are good in C, definitely your Python programming will be very easy, very easy. So whatever the fundamentals and logics are there, you can use, are going to use in the Python programming. Okay, so C is the basic. So you should be thorough in the C language, even for learning or even other programming languages. So other than this, what we are going to study, mathematics, you are containing partial differential equations, numerical methods. So these are the some engineering subjects. Professional core 1. So mechanics of solids you are going to study, thermodynamics. So thermodynamics means whatever you studied in the physics, no? First zeroth law of thermodynamics, first law of thermodynamics, second law of thermodynamics, like that. So you are going to continue an application again. So in the thermodynamics, you are going to study that applications. Whatever the laws of thermodynamics are there, we are going to study. So materials of solids, what are the different, actually another name is the strength of materials, also will call this kind of course. So different structures, how the forces are acting. These are the things we are going to study. And if you see, this is the one thing, automotive chassis. This is related to the automobile. First automotive course related to the automotive, we are going to study here in the automotive chassis. So here, along with the laboratory, you are going to understand how exactly different types of automobiles are there, how different type, what are the different elements or subsystems are there in the automobile, and what is their role, what is their functionalities, and what are the different types. So okay, these are the things we are going to discuss in the first the automotive chassis. So suppose to give an example, suppose in automobile, if you see, we have the chassis, one thing we can call, basically it's a structure. Basically it's a structure on which different systems are attached. So chassis is nothing but our body without clothes, we can say. Chassis with other body, we can call it as a complete vehicle. Body is means something, seating arrangement will be there, even other overall other body, along with the body we can call a vehicle. So with removing the seat and the body, we can call it as a chassis. So to the chassis, most of the systems are attached. So like a steering system is there, braking system is there, engine, which is called as a power plant, basic energy source for that vehicle. So all these things are attached to that thing. We are going to discuss like a braking system, suspension system, steering system, engines. These are the things we are going to study in the automotive chassis. And some chassis we are going to discuss in the, we are going to have the hands-on practice on the chassis laboratory. And materials is also one of the important thing. What are the different materials we are going to use for engineering applications? Suppose a vehicle is there. Vehicle, we have the different components. Every component is having the different functionality. Based on the functionality, you have to select the materials. All the materials cannot be plastic. All the materials cannot be metal. All the materials cannot be aluminum or steel. So based on the type of application, based on the functionality, we have to select the materials. So that kind of thing we are going to study in the metallurgy and materials engineering. So lab is also there. We are going to have hands-on thing in a lab, metallurgy and materials. So these are the things you are going to study in the third semester. And fourth semester, you are going to study the fluid mechanics and machinery, like turbines. Suppose common applications, what you can observe is some fluid mechanics, machinery, just the pump, whatever common application, whatever you are using in the household application, simple water pump, along with the motor. So these are the, we have the turbines for the power generation, hydraulic power plants, whatever the fluid mechanics and machinery applications are there. These are the things, fluid mechanics. These basics also we have already studied in the physics. Actually, we are going to continue as a engineering application. So next one is applied thermodynamics. So whatever the thermodynamics you have studied in the third semester, you are going to continue with the, again, application. So how this power is generated in the thermal power plants. So what are the things are there? Steam turbines, steam engines, like that. Even air conditioning, how the air conditioning, what are the air conditioning basics are there, how the refrigeration, these kind of, whatever the engineering applications are there, thermal applications are there, we are going to study in the applied thermodynamics. So applied thermodynamics you have there studied in the third semester, and we are applying that thermodynamics in the fourth semester. Theory of machines, again, this deals with the mechanics and machines. So how the mechanisms are there, how that machines are working, okay, effort, force, these are the things they are going to learn in the theory of machines. So if time permits, I will go through the detailed syllabus. Let us discuss the structure of the thing. Then another more related subject is automotive engines. So of course, all the subjects are compulsory, are basics, fun wonders for the engineering, automotive engineering. So, but here automotive engines, especially core, I can say, they're mostly into the automobile. Directly, we can feel that thing. So, engine is the main thing, heart of the vehicle. So, we are going to study about that engine. So, nowadays, we can see MPFI engines we will call CRDI and so like that different engines are there. How these the engines are working? What is the basic principle? What are the different advancements in the engine? And now we are getting the pollution. No? A lot of pollution is coming from the vehicle. How this pollution is coming out and how we can control this pollution. These are the basics we are going to study in the automotive engines. And along with the laboratories also there, automotive engines laboratories are. So not only the theory study, in the laboratory, you will be having the completely engines. You can dismantle the engines, you can assemble the engines, you can see the micro level, you can see all the parts available in the engine by dismantling the engines. And you can test the engines. So how much power is there, how much power you are getting, how to test that engine. These are the things you are going to study have the hands-on in the automotive engines and automotive engines laboratory. And FMHM, I mean, fluid mechanics and machinery lab is also there. Along with that thing means you are going to test different types of pumps, reciprocating pumps, centrifugal pumps, turbines, different types of turbines. All these things you are going to test it in the laboratory. And theory of machines, like mechanisms, basic. So theory of machines, whatever the machines are there, mechanics linkages are there, how the linkages and mechanics are going to work and how they are applicable in the engineering applications in automobile. These are the things you'll be having the hands-on in the theory of machines. And one more subject, manufacturing. So for the manufacturing of automobiles, so casting and the machining process, the forging process, foundry process, whatever it is there, you are going to study all the manufacturing techniques of engine components, other vehicles, even other engineering components, not only the automotive components, what are the common engineering components, how they are manufactured, how they welded, how they fabricated, how the machining will be done, everything, how the finishing will be done, all the basics and will be studied in the manufacturing technology. And we have the lab also in the next semester, in the 5th semester, of course. So in this semester, we have the 21 credits. So at the end of the 4th semester, you are going to have some idea about the automobile engineering and what is automobile, what is the different types of vehicle, how the different types of bodies are there, what is a hatchback vehicle, what is a sedan vehicle, what is SUV, what is MUV. Like that you can able to differentiate different type of vehicles and what are the different technologies available and what is the different kind of engines are available, petrol engine and diesel engine and again the petrol engine, diesel engine also, what are the advancements and how the emissions are there. So how they test the emissions. These are the things we'll be studying at the end of the second year. So whatever the studying fundamentals you are studying in the first year, and the second year you will be familiar with the automobile. So here I will give the simple analogy basically. So petrol head is a term what is used for the person who is having is an intense interest in the automobile. Suppose if you see the analogy, you can see here. So first one is you can see basic heart. Engine is heart. For human, heart is the basic thing, primary. And similarly for the automobile, engine is the heart, primary thing. Without engine, we cannot run the vehicle. Without engine, we cannot run the vehicle. So here also same thing. Without heart, we cannot live. Same thing here. So here is the heart is a primary thing where we are going to study in the second year itself. So in the previous second year, we are going to study how the engines, what are the different types of engine, how it works, and what are the different advancements. These are the things. And one thing is the ECU. So the ECU, brain, this is the brain. So for operating the engine as well as the other elements, other systems, ECU will be the main thing. So even for nowadays, we are having the electronic fuel injection systems in the engine. Earlier days, if normal mechanic can repair the vehicle, even cars, if you see, normal mechanic, roadside mechanic can repair the cars. Nowadays, it is not possible by the common roadside mechanic, because nowadays these engines are having more of electronics, more of ECUs. So ECU means your efficiency. We are taking the means ECU means simply is a computer microcontroller basically, which decides the functionality and which increases the overall efficiency of the system. So ECU will decide when to start the engine, when to off the engine, how much speed, how much load, and to overall to maintain the efficiency, what are the different parameters we need to take care. These are the things it will take. So air intake is the one thing, like a human breathing capacity. Similarly, we have the air intake through the nose. We are bringing even some vehicles also. We have some kind of intake system will be there through which air will be taken into the vehicle, into the engine basically. So then we have the, for us we have the air filters like lungs, which filters the air. Similarly, in the vehicle also we have some kind of air filters. Oil filters also will be there to filter the oil. Even fuel filters also will be there to filter the fuel, so that there won't be any foreign element should be entered into the system. And fuel injection system. And here one of the thing, stomach basically the thing where combustion takes place. In kind of humans, we call it as a digestion system. Whatever you take, carbohydrates basically, food in terms of food, carbohydrates, whatever you take, these are the things they are going to digest here. Whereas in the same thing, we can call in terms of automobile, we can call it as a combustion process. Suppose if you carbohydrates, no, whatever you take, for vehicles, petrol or diesel, it's a hydrocarbon basically. Only the structure is going to be different. Hydrogen carbon will be there as usual. Only the structure is going to be different. So the kind of food what you are taking, same, and that kind of food what you are giving to the vehicle is also more or less same. There we are taking the carbohydrates, and to the vehicle we are giving the hydrocarbons. Structure is going to be different. Chemical structure is going to be different. So here combustion takes place in the automobile, whereas here digestion takes place. So if this digestion is good, your vehicle efficiency is good. If this digestion is good, your emissions will be less. Similarly, automobile also, your combustion is very good, your efficiency of the engine is good, your mileage is, in terms of simple common language, mileage. Combustion, if you have good combustion, good efficiency, your mileage will be good. So generally antuntanga, how many kilometers per liter? Suppose if you go in through highways, you will have good mileage. In the city, you will have less mileage. Some reasons will be there. We'll discuss anyhow that in the course. So what are the reasons why that incomplete combustion or incomplete digestion, if you come to the human beings? So why the emission is there? These are the things we are going to discuss. So we can, so other parts also, if you can see, other parts also, some headlights and even for the tires and so like that, there are so much similarity between that human being as well as the automobile. So if you love your body, obviously you love automobiles. Okay, so this is the analogy I can think, so that to create much interest in automobile engineering program. Along with that, this is the thing what you are going to study in the automotive chassis. So this is the exploded view. So this is the what you call as a frame. On the frame, we are going to attach different kind of components basically. So we are going to study that. So what is, and next to that, you are going to study about the engine. So I am comparing with the heart. So primary for automobile, engine is the heart. So whatever the things are happening in the heart, similar kind of things are also there in the heart. So in the heart also we have the valves. In the engine also we have the valves. Like that. Engine basic heart is the main the power. Here also engine develops a lot of power basically. So these are the things. There are some similarities between the engine and the heart. We'll discuss interestingly in the class these things still in detail. In the 5th semester, after the second year, in the 5th semester, so we entered, you people entered the 3rd year now. So we are studying the heat transfer, automotive, electrical and electronics. So the systems related to the electrical and electronics in automobile engineering and the design. So we are going to design some of the engineering components, how to design the engine, how to design the frame, how to design the suspension, how to design the braking system, so how to design the body of the vehicle. So these are the whole things, fundamentals, whatever there, we are going to discuss in the design of automotive components 1. Parallelly, automotive components 2 will be there in the 6th semester. So you will be thorough in the design of different automotive components. So these are the professional electives. So here, out of the 5 professional electives, you can choose any one of the professional elective based on the interest. So one thing is alternative fuels. Second one is the simulation of automotive engines, mechatronic systems, unconventional machining process. So based on the field of engineering, suppose this is more related to the different types of fuels like LPG, CNG, hydrogen, fuel cells, and like this. We are going to discuss different types of fuels. What is the benefits and advantages, and these are the things we are going to discuss in the automotive fuels. Simulation of automotive means we are going to more on engines. So we'll simulate the engines in using the even some softwares also. So mechatronic systems, where we have the mechanical as well as electronic combination systems. Unconventional machining process means other than the some latest advanced machining process we will be discussing here. And quality engineering, whatever the engineering components are there, we need to check, we need to verify the quality of that components after manufacturing. So what are the different types of techniques are there, how to verify the quality of the components, what are the different techniques are there, different methods are there, we are going to discuss in this thing. So based on your interest, you can select any one of the professional elective. So that depends. So you will be in the 3rd semester itself, you will be having the professional electives as well as open electives. So this open elective story, you people have the 4 open electives. In the 5th semester, we have the open elective 1. In the 6th semester, we have the open elective 2. 7th semester, open elective 3. And 4th semester, open elective 4. So here, advantage, I will give the thing here for understanding. Yes, where is that open elective? So this is the open elective track. Here you can in the 3rd unit itself, you can select this track basically based on your interest. You can see here we have the smart cities offered by the track offered by the civil engineering, waste management offered by the civil engineering, green energy offered by the EEE department, 3D printing and design offered by the mechanical engineering department, Internet of Things offered by the ECE department, augmented reality and virtual reality offered by the ECE department. Similarly, artificial intelligence, blockchain, robotics, cybersecurity, data sciences, autonomous vehicles offered by the automobile. So whereas this autonomous vehicles track you people cannot select, this is for the other engineering branches. Other than automobile engineering branches, this track will be given. Don't worry, these things you will be studying in your course anyhow, program. Compulsory, you need to study this kind of subjects. It will be there as usual. To create some good knowledge and to give some familiarity, awareness about the automobile and latest technologies, introduction about the latest technologies, we are offering these courses for the other than automobile engineering students. So here advantage is, you can observe here, advantage is people can take any one of the track, so that you will be good knowledge, and based on your placement requirements and based on your future studies, higher studies, even in MS Kani, MTech Kani, whatever it is. So based on your interest, you can select this kind of tracks. Suppose artificial intelligence is there, you have the 4 subjects in this track. So 5th semester, 6th semester, 7th semester, and 8th semester. Like that, you need to study every semester. You need to study any one of the open elective. So you will be familiar with one track completely. So cyber security, you are interested in the cyber security, you can select this track, and you need to select all these 4 subjects. So if you are interested in the data sciences, you can select this. Or if you are interested in the Internet of Things, you can select this track. So based on your interest, you can select these open elective tracks, and you will be more familiar. Okay, so this is about the open elective tracks which are offered from the 3rd year onwards. So we'll go back to the 5th semester. Yes. So these are subjects you studied in the 5th semester and the 6th semester. These are the subjects: engineering, economics, accountancy, which is a management subject, CAD CAM, design of automotive components, vehicle dynamics, which are aerodynamics of, you will be studying some aerodynamics of the vehicle, dynamics, ride quality, handling of the vehicle, how that dynamics of the vehicle. Basically, when vehicle is moving at high speed, what are the forces acting on the vehicle, how the toppling of the vehicle happen in the accidents, so how to avoid. These are the things we can study in this vehicle dynamics. So along this, we have the professional elective 2, where we have this kind of subjects: automotive pollution control, mechanics of machinery, automotive embedded systems, which are related to the electronic applications in the embeddeds, or otherwise microcontrollers in the automotive. So if you want to have some kind of electronics in automotive application knowledge, you can take this automotive embedded systems, aerodynamics of road vehicles, industrial engineering, and open elective 2 you can select based on the track you opted in the 5th semester itself. So, and these are the subjects. So at the end of the 3rd year, you will be more familiar with some of the advanced vehicle technologies, mainly automotive, electrical, and electronics. Suppose engine is there. In the engine, what are we have different things. Conventional things are there earlier. Conventional ignition system is there, and now it is electronic ignition system. And some starting system, how self-starting antam kada, how engine is get started when you go for the ignition. So these are the things. What are the technologies available? These are the things we are going to study in the things. What are the different sensors are available in the automobile? These are the things we are going to familiar. And what is the electronic fuel injection system? What is the ACC, adaptive cruise system? So these are the things. Additionally, you will be going what is GPS navigation system, which is helping in the navigation of the vehicle. Adaptive cruise system, where we can completely no need to press the accelerator. Without your accelerator, your vehicle will automatically will increase the speed or decrease the speed or maintain the speed based on the road condition. So cruise can automatically, it will cruise. So airbags, how the airbags will, what is the collapsible steering in case of accident, how the steering get collapsed, so that to minimize the damage, personal damage. So anti-lock braking, ABS, keyless entry, immobilizer. So electronic keys are there nowadays. So how they are working, number plate coding. So nowadays you can see at the toll plaza how that vehicles are going without. So no need to stop for paying this toll plaza. Okay, directly you can pass by. We have the sensor by seeing the number itself, how the your amount will be debited or credit from the your account. These are the things you can study, how the active suspension. So whatever the advanced advances, basically things are there in automobile, we are going to study in the 3rd year. You will be more completely familiar along with some other subjects like design, manufacturing. These are the even things we will be studying. Whereas in the 7th semester, you are going to study about the electric vehicles, hybrid vehicles, autonomous vehicles. And as usual, we have the professional elective 3, professional elective 4, and open elective 3. So in the professional elective 3, we have these things: vehicle body engineering, automotive materials, automotive control systems, noise and vibration, mechanical measurements and metrology. These are the different subjects. And here thing is, one important lab I can say is automotive simulation laboratory. So this is the new lab which is developed in automobile engineering department. Basically, from your 19 R19 batch and even R18 batch is also there. So vehicle maintenance and testing is also one thing where we are going to test the vehicle completely. So how to maintain the vehicle, how to test the vehicle, these are the things we are going to study and do the laboratory exercises in the. So in the 7th semester, we have the only electives, 2 professional electives, 5 and 6, and 1 open elective 4. So in the fuel cell technologies, CFD, computational fluid dynamics, automotive testing, automotive product development strategies, flexible manufacturing, 2 and 3 wheeler technologies, auto air conditioning, automotive instrumentation, special purpose vehicle. So this is the other than the automobile, like even heavy vehicles, not even generally what we call buses are there, trucks are there, cars are there, two-wheelers, three-wheelers are there. Other than that, we have some special purpose vehicles. So we are going to discuss that as special purpose vehicles in this course, special purpose vehicle. So, and we are going to do the project. So in the 7th semester, I mean 4th year beginning itself, we are going to start the project that will be continued in the 8th semester. So the total 6 credits here in the 8th semester and 4 credits in the 7th semester. So this is the overall structure of automobile engineering. So you are going to complete 8 semesters. So in the 8th semester, at the end of the 8th semester, 4th semester, you will be familiar with the electrical vehicle and what are the different components in the electric vehicle, like engine is there, motor is there, and some kind of controllers will be there, and batteries, different types of the batteries. And nowadays we are having electric vehicles. Completely, the trend is going to be next 5 years. Your trend is when you are going going out of the college, you will be seeing the different kind of trend in India. The most of the vehicles are converted into IC engine powered vehicles nowadays. Whatever you are seeing, mostly they will be converted into towards electric or hybrid vehicles. So that technology we are studying in advance actually here, so that you will be more ready even for the industry demand. So that what the industry want, you people are going to be ready with that. So these are the technologies. So hybrid means definitely you need fuel tank as well as a electric charging. So you can go for that, anything, either charging or fuel tank. So if it is a hybrid vehicle, electric vehicle means only motor, battery, controllers, charging, these things will be there. So based on the application, you can, in the future, you are going to see the change in the trend actually, whether the electric vehicles are going to dominate, or hybrid vehicles are going to dominate, or fuel cell vehicles are going to dominate, or solar vehicles are going to be dominated. You are going to see that change and trend. And along with, you are going to study about more about the autonomous vehicles and connected vehicles. Means here driverless cars, self-driving cars. Mostly everything is sensor. We are going to be relaxed. Here also we have different levels, basically 0 level to 5 level 5 up to level 5, 0 level 1, level 2, level 3, level 5. How the autonomous is going towards complete autonomous. So level 0 vehicle, level 0 means it's completely conventional vehicle. We are going to control the vehicle completely. Level 5 means it's a completely hands-free and you are going to be relaxed completely, and the vehicle will be taken completely driverless car. So you are going to select the destination, from the origin to destination, your vehicle will be taken care. So there are different kind of technologies are there. You are going to study and you are going to witness these technologies in your program, throughout the program. So supporting to that technology, whatever the basics are there, fundamentals are there, related electronics, electrical, and all these things we are going to study. So this is the thing you can see in the future. These are driverless cars, I can say. These are the autonomous cars. They were going like a systematically in a track, and connecting and talking to vehicle, to infrastructure. So if there is vehicle is going to come near to that, automatically it will give the kind of signals. Okay, or otherwise that vehicle has to be taken some kind of care. So automatically some obstacle will be taken care. Automatically your destination is once you decide the destination, route will be decided by the vehicle itself. So everything is autonomous. So autonomous and connected vehicle technologies we are going to study in the final year, basically. So, and these are the different leaders at present who are in the autonomous vehicle technologies, you can see. So in the telematics side, these are the different manufacturers are in the ADAS means advanced driver assistance systems, like that ABS kani, ACC kani, where the technologies basic for the autonomous vehicles, navigation, GPS, what we call now GPS, automatic Google map is near, we can go. So GPS and autonomous driving systems and cloud system, because always whatever the system we have, electronic system, computer system, cloud services are compulsory, because somewhere you have the control and somewhere you want to driving the vehicle means, suppose anything happens to the vehicle, immediately that communication will be given to that to the mother center, or otherwise to the service center. Suppose a simple example, suppose you are going on a highway, you met with some accident, immediately that information will be given to the some nearby police station or nearby hospital, or to that services, whatever the services we have. So this kind of technologies automatically will be, without your intervention, without your knowledge, will be communicated. So there will be some kind of communication between the vehicle to vehicle, communication between the vehicle to infrastructure, communication between vehicle to the some kind of services, whatever it is. And suppose vehicle needs some services, immediately that will be informed to the driver, okay, take me to the service station. Like that, automatically everything will be done. And infotainment system, nowadays you can see kind of entertainment system what you have in the vehicle. So still advanced infotainment system we can see in the future vehicles. So these are the different manufacturers and the leaders in the kind of connected and autonomous vehicle technologies. So, and you people are at the end of the 4th year, you people are going to have the knowledge about all these vehicles, and definitely I'm sure you will be seeing or witnessing these technologies on the road at the end of 4th year, or and next 5 years you can see this kind of technologies on the road. So future trends, electric vehicles, fuel cell vehicles, solar vehicles, we are going to see definitely the change you can see. And these things we have discussed, open electives, and okay, at VNR VJT finally what you are doing. So after learning the AutoCAD and different kind of CAD and modeling softwares, and they are going to model the vehicle. This is the model what developed by our students. We are going to analyze that model. So if the vehicle meets with the accident, or even during the dynamic conditions, how that vehicle, different forces are acting on the vehicle, whether the vehicle is stable or not, whether the vehicle can work or not. Okay, and finally this is the prototype developed from the vehicle, which is participated in the some Delhi Buddha track in the New Delhi. So this is the CAD lab. So we are going to design this in the CAD lab, where you have very good CAD lab and good advanced softwares and all these things. You can develop these things. And this is the SAE lab supporting to the CAD lab. In the CAD lab, we are going to model and analyze. In the SAE lab, we are going to make the prototype. Society of Automotive Engineers. So here most of the students work day and night actually. So they are participating different competitive events like SAE Baha Kani, SAE Supra Ani, or aero competitions, different electric hybrid competitions. They are participating. They are going to the Coimbatore. They are going to even Madhya Pradesh, Gurgaon, even Delhi. They are participating in the different places, and they are contributing at good recognized places also they achieved in the competitions. So this is a vehicle, just to have the video which is developed in the thing. Okay, not able to. Okay, I will. So that is about that is a vehicle you students develop in the labs basically. So we are also expecting the similar kind of prototypes in the labs. Okay, అవునా ఏమైందో అవునా వాయిస్ బాగానే ఉంది ఏమైందో ఇప్పుడు మేడం ఓకే సో దీస్ ఆర్ ద vehicles kind of vehicles what they yeah so your seniors made these kind of vehicles in the labs using the CAD lab as well as SA lab and the tech and whatever the things they have studied in the classroom they applied in the labs and they participated in the different competitions basically. So you people also, if you are interested in the first year itself, you can take part and take the SA membership and you can participate in this kind of events and you can get the good placements also along with this thing. So at the time of competitions, different good manufacturing automotive manufacturers will be coming like Mahindra and Mahindra, Ashok Leyland, and most of the companies they will be coming visiting these places and they recruit the people also directly. So along with the campus placement, you will be having the off-campus something like at these competitive places also. Okay, and so these are the just for exam. This you might have seen in the previous slides. These are the different kind of vehicles what your seniors have developed in the as a part of the project works. This is a micro car, a completely electric micro car. This is a solar in a hybrid car, I can say. Solar engine is there, IC engine is also there, electric. So combination of electric, solar as well as IC engine power. And this is a Formula car, which they participated in the Japan also, developed in the college. And this is the campus electric vehicle. Nearly it's a 10-seater, I think. So 10-seater electric vehicle, bigger one. And it's an electric micro car, 2-seater. And interestingly, last year they developed, and 2 years back they developed, and last year they have developed, try to develop autonomous kind of technologies. They have tried to adapt it by extending this project work. So in the electric car, they have implemented this autonomous vehicle. Like automatically it will take the track. Automatically it will identify the obstacle and apply the brakes and destination. Everything will be done autonomously. Like that kind of technology they have applied here in the electric car. And this is the one which is a foldable electric bike manufactured by your. So if you see these kind of vehicles, they developed in the span of 4 to 5 months basically. Means 4 to 5 months span they developed this kind of vehicles, and they utilized complete used the complete knowledge whatever they gain in the 3 to 4 years of course. Okay, so these are the few projects has been related to the electric and hybrid field, because I'm basically in the electric and hybrid vehicle side. So that's why I have shown only this kind of vehicles only. Other than this, they have a lot of projects, even embedded system related, using the microcontrollers, using the manufacturing side, very good rapid prototyping, 3D printing side also they have developed. So many things are developed. Just a glance of projects which are related to the automobile and related to the electric and hybrid only I have shown here. So that's about thing, and I'm not going to discuss because already time over. Next faculty is waiting, so I'm not going to discuss much about the job profile and all these things and what are the different skills you need to be acquired during the 4 years. Okay, we'll discuss these things in the future anyhow, in the time permits. So that's all. Thank you very much. Thank you for the patience listening.
Yeah. Thank you, sir, for presenting a clear glimpse of automobile engineering course structure along with various projects of automotive industry in India. So especially students have got a clear understanding of an automobile with your petrol head anatomy explanation. Thank you, sir.
Thank you, madam.
Yeah, students, now I am sharing the feedback link in WhatsApp group. Please give your valuable feedback.
Yeah, now I would like to introduce our next speaker for the session called Career Vision Approach by Mr. GVL Prasad. I welcome you, sir.
Madam, hello, madam, go to me.
Sir, tell me, sir.
Okay, 5 minutes.
Yeah, okay.
Student, first give the feedback, then we have the next session. Okay.
In 5 minutes, start the next session.
Sir, Amjad sir, a few questions are there that I'll ask you. Sir, Amjad sir,
సార్ చెప్పండి.
okay.
బట్ హలో.
So, sir, one of the guy is asking, can you provide this PPT?
ఓకే, విల్ ప్రొవైడ్ సార్. షూర్, వై నాట్.
Okay. Okay, sir. And one more thing, syllabus. Where do we get the syllabus?
యా.
Hello?
Sir, we can get in the website, sir, actually, these things.
Okay.
You can get these things in the website.
So you can go to the college website in the academic section. If you can find this kind of details, what is the structure and detailed syllabus also, you can it is available in the syllabus. And
Can I share my screen and show it there? How to download it?
sure, you can show it, sir. Why
Okay.
not?
Only 2 minutes. I'll share my screen. Please, student, please observe now. Here, this is what our website. So here, if you go to the academics, click it here. Then if you scroll down, here you will get syllabus books option, right side. Again, click it. Here you will get 2 tabs: BTech syllabus books and MTech syllabus books. And enter into BTech syllabus books. And here you can able to observe. Download BTech syllabus R19. Your regulation is R19. First year. For the first year, just select AE. AE stands for Automobile Engineering. If you press it, then you'll get this. Total 36 pages Word document is there. Sorry, PDF document is there. You can download it from here. Otherwise, I will share by today evening. The syllabus I will share by today evening. Okay. Okay. Thank you, ma'am. 1 minute.
Even the regulations also they can go through the academic regulations
1 minute.
thing.
Yeah.
Yeah.
Yeah. From here you will get academic regulations. Both I will send by today evening. Okay. Otherwise, right now I will share. Within 2 minutes I will share. Please go through it. If you have any doubts, feel free to contact.
So these regulations are common for R18 as well as R19. I
Okay.
hope.
Both are same. Yeah. Same only.
Yeah.
Okay. I will share these two documents in your WhatsApp group by today evening before 4:30. Okay. Right. So still any doubts are there, then you can just text in the chat box so that I mean, sir will give the answer. And those who don't have any doubts, please give the feedback. Please provide your college mail ID. In the morning, your mentors has provided a college mail ID. So please write down that mail ID. Okay. So Amjad sir, thank you very much, sir, for your valuable session. People are very much interested about your session. Why? Because few people are asking your PPT also. Please kindly forward me that PPT so that I'll share this to my students.
Okay. Thank you. Thank you very much.
Uh, okay, sir. Thank you, sir.
Bye.
Thank you very much. Madam,
Yeah, shall we begin, sir?
so we will begin. Okay, sir. Okay. Ma'am, do you want to introduce the session?
Yeah.
Okay.
Yeah, let me quickly introduce our next speaker that is Mr. GVL Prasad Garu. Welcome, sir.
Thank you.
Mr. GVL Prasad working as Assistant Professor in the Department of Automobile Engineering, PNRVJ IIT. He is enthusiastic, department training and placement coordinator, and he has 17 years of teaching experience. And his research areas are IC engines and alternate fuels and advanced driver assistance systems. And moreover, Sir has patents also in various areas. And I welcome you, sir. You can start the session. Thank you.
Thank you, madam. A window better. Thank you. You can present. You can present from here. Okay. Okay. 1 minute.
Just a moment. There is small technical issue.
Sorry.
Okay, no problem, no problem.
హలో ఓకే ఇప్పుడు వచ్చిందా పీపీటీ రాలే ఓకే Okay, okay, 1 minute. Am I able to, are you able to hear me?
Sir, yes, sir, your screen is visible to us.
Okay, am I audible also? Am I
Yes,
audible?
sir. Yes, sir, you are audible.
Okay, madam, thank you. Okay. Good afternoon, everyone. Warm welcome to student induction program. Today, I would like to brief about the career vision approach. Career vision is all about crafting the mental image of the student future. It describes the ladder of career. CVA gives an overview of the opportunities available after completing their studies. It gives them information about emerging trends in all fields of engineering. It serves as a platform to fill the gap between the academia and industry. Through CVA, student can visualize the nature of work he or she engaging after completion of a graduation. CVA Promotion Center provides resources like TED videos, upcoming courses, self-learning videos, and innovative and creative learning. Coming to initiatives and differentiators at VNR Vijayati, uh, education process. Change. Education process re-engineering, career vision approach, VNR lab protocol, shadow engineering, integrated RCC with innovative practices, MTP and student matrixing, mirror engineering, and why autonomy and its relevance. Coming to this re-engineering, the institute has initiated uh, education process reengineering EPR, which will bring the phenomenal changes in academic, administrative, and managerial process. 1 minute. So, okay, okay, fine. The institute has initiated education process re-engineering, which will bring the phenomenal changes in academic, administrative, and managerial process, greatly benefiting to all the stakeholders. Here, the stakeholders are students, parents, and employers. Let us come to these four aspects of education process re-engineering. Let us consider a pyramid. Pyramid has a four phases. In each phase, oh, the major functions are ex, excellence in excellence in academics, exploration of knowledge through research, excitement of innovation and entrepreneurship, exponent for development of a rounded personality with global vision and social responsibility. Coming to again education process re-engineering, let us divide this total pyramid into four blocks. So each block considered as a one deck. So each deck has certain things. One deck is a policy, strategy, resources, operation, and quality assurance.
Sir, lagging, sir, slide.
Sorry for the interruption.
Sorry for the interruption. Just wait for 1 minute. We have some technical issue. Okay. Yeah, yeah, yeah. Okay, come to career vision approach. Here, in a career vision approach, student faculties are involved. The target career for the students are research, concept and innovation, design and development, test and validation, manufacturing and quality systems, analytics and post-delivery services, entrepreneurship. So these targets of the students can be achieved through campus learning. So the campus learning consists of classroom learning, tutorial, lab work, self-study, open source, others and industry research and projects and seminars. In the classroom, students going to learn at 20%. So remaining in the tutorial classes will be taken, where the tutorial classes will be 2-3 faculties are involved for the same subject. They have given some questions and they'll help to solve in the classroom itself. So through the practice, they will learn. So in the lab work, they are going to conduct some experiments. When you come to the lab work, there are some VNR lab protocol is there. So we'll follow certain rules to conduct the lab. There is a physical labs and simulation lab and net-based labs. So come to self-study and open sources. Nowadays, students have a wide opportunities to learn on their own. We have online platforms like NPTEL, Coursera, etc. They can learn on their own. And industry, through industry, they can learn through shadow engineering. So I'll tell you what is the shadow engineering in the next slide. Okay. Come to career vision roadmap. In the first year, students are going to orient career vision approach is there. So orientation and matrixing with the senior students, insight into engineering career options, and TED videos. The TED videos are the technical entertainment design videos. So in an induction program, we are going to show some TED videos. So regarding various technical aspects. Then come to second year. In the second year, there is a shadow engineering and mapping to industry competencies. Come to third year. So fine tuning of career vision. In the third year, workplace technologies, technical papers and projects, assessment on soft skills, mirror engineering, preparation and planning for higher education. And coming to fourth year, reaching a career vision. So it's the final year. So students are going to complete their graduation in this year. So it is very important. So industry relevant project, campus placements, corporate readiness program, and higher education. So this is how a career vision roadmap in a 4 years. So career vision approach for a lab protocol. So this career vision approach in a lab protocol can be divided into 4 layers. So each engage layer, involve layer, indulge and accomplish. In an engage layer, students will see the whole scenario. If you look at the industry perfect, in an engage layer, student will involve and observe the whole industry. Then coming to next layer, in an involve layer, students are going to visualize the whole 2 parts. What are the parts are there in the industry? They will observe the parts. In an indulge layer, students are going to involve, exercise and experiment with the parts. And then last, accomplished layer. In the accomplished layer, parts to whole scenario. And again, whatever the students are learn about the parts and equipment and those parts, how important the industry. This is the whole scenario. So this can be achieved through career vision, real world situations, shadow engineering, lab resources, general lab introduction protocol, research, pool and setup, study and appreciate, dexterity and skill, part achievement, correlate and experience, imagine and create, sum total achievement. Career vision approach is a success is a sum total of small achievements. Then come to VNR lab protocol. The aim of the lab protocol is to structure and conduct the lab course with a career vision approach and as a continuous process against the present practice of conducting experiments in an isolation situation. So we are not going to conduct the labs in isolated way. Here we give the entire scenario of the real world situation. To continuously map a lab work onto classwork and syllabus to enhance the depth of learning. In this process, the student will know why is he learning in the class, what he is learning. Thirdly, to engage, involve, and indulge the student to make them more imaginative, creative, and independent in problem solving through design and planning of experiments rather than just conducting experiment. To actively involve, not just present, the students in lab work by making them feel that they're accomplishing a major project or task out of their experiments in the lab and current classroom learning. To impress and inculcate 7 habits of highly effective people. I have a separate slide to explain 7 habits of highly effective people. I'll show you. As a part of lab procedures and protocol, this training not only helps them to complete their experiments and projects successfully, but also to become a good professional and a leader. To make the students industry ready by making the lab itself look like a virtual industry, to impress the value and use of a traditional and classical lab concepts and skills and intellectual and manual dexterity, to establish metrics of for students skills with respect to placement and industry readiness. This is how we are going to conduct the lab with certain protocols. So this is the very important slide. 7 habits of highly effective people. The students should have these 7 habits. They should adapt. First one, habit one, be proactive. This habit is a choice. See alternatives, not roadblocks. Focus on what you can influence. I am free to choose and I am responsible for my choices. Then come to second habit, begin with the end in mind, a habit of vision. So mental creation proceeds of physical creation. Define a practical outcomes. When you are going to start anything, you should be think that where you are going to land finally. You should start with the end in mind. What should be your outcome? So that should be. Then third habit, put first things first. The habit of integrity and execution. Focus on the important, not just the urgent. Effectiveness requires the integrity to act on your practice priorities. Plan weekly, act daily. So this is the thing. Habit 4, think win-win. The habit of mutual benefit. Effective long-term relationship require a mutual respect and mutual benefit. Build trust with the co-workers. So you should have, before going to start anything, we should keep in a mind that we should going to complete this and think win-win situation. Fifth one, seek first to understand, then to be understood. The habit of mutual understanding. To communicate effectively, we must first understand each other. Practice empathetic listening. Give honest, accurate feedback. First before going to start anything, you should understand first, then understood. Synergize, the habit of creative cooperation. The whole is greater than the sum of its part. Synergize to arrive at new and better alternatives. Habit 7, sharpen the saw, the habit of renewal. To maintain the increased effectiveness, we must renew ourselves in a body, heart, mind, and soul. Sharpen the saw. We should upgrade our knowledge every day. We should be sharpen the saw. So, at VNR VJIT, we are practicing all these 7 habits of highly effective people. So, then there is a one important thing. I'll show you 4 quadrants. Let us look at this small thing. So quadrant 1, 2, 3, and 4. Let us look at urgent, not urgent, important, and not important. So certain times we have a many tasks to complete. You know. So in a quadrant 1, urgent and important, do complete it. The second thing, not urgent but important, plan. The third quadrant, urgent, not important, delegate. Quadrant 4, not urgent and not important, eliminate.
Hello. వస్తుంది. Hello. Hello. I'm audible.
Sir, your screen is not, yeah, now it is visible.
Okay. Am I audible now?
Yes, sir, your screen is visible and you are audible.
Okay. Okay. Thank you. Yeah, hello. Coming to this four quadrants. So here, these four quadrants divided into urgent, not urgent, important, and not important. In a quadrant one, urgent and important. First, we should complete this thing. So when a question arises, we have many tasks to complete, and which task I have to complete the first. Then you have to follow this rule: important and urgent. First, you complete it. Next, second thing, you go to second quadrant, not urgent but important. So then you have to plan. So next, coming to third quadrant, not important but urgent sometimes. So this should be a delegate. Then a fourth one is not urgent and not important. So that should be eliminated. Okay. So this is the thing you have to follow when certain tasks to complete. Then come to shadow engineering and mirror engineering. So faculty and students to work in an industry for 1 week per year under the shadow or guidance of a industry expert to know current industry practices to improve the teaching through industry knowledge. So in a second year, a group of students from all branches will be taken to one industry. So where there are different departments available. So the student, each branch students will be allotted to that particular section. So they are following one delegate or person over there, and whatever the task is completing, students is act like a shadow, and then he will learn. So whatever the thing we are doing in an industry. So this is the thing what is happening in a shadow engineering. Then come to mirror engineering. Then what is a mirror engineering? Mirror engineering will be mostly conducted in a third year BTech. So in a mirror engineering, students will go to the domain specific industry. In a shadow engineering, students will go a particular industry. All branch of students go there, and then they will work under different departments. But in a mirror engineering, we'll select a specific domain. Okay, so for example, for an automobile engineering students, we will select a companies like automotive, Mahindra and Mahindra. Students will go to the Mahindra and Mahindra. They're completely in that automotive parts or automotive are developed. Students are going to engage there, and they are working, and they are observing 1 week how the product's life cycle is there. So it is like a mirror what is happening in the industry. So these two things are conducting in a second year and third year. Then come to shadow engineering. So these pictures are this already your senior servant is on Kirti Industry, it's civil factory. So the students are went there. The pictures was taken at that time. So the shadow engineering is excited to debut an innovative program called shadow engineering. This new program allows prospective engineering students to see industry from a professional perspective and allow them to spend a week time with the current engineering practices in the multidisciplinary areas at the industry and see what industry life is really like. Visiting students will go around the industry, see the manufacturing process and facilities, and most importantly, get time to talk with working engineers about their experience. The shadow program is an opportunity for freshmen, sophomores, and juniors to learn what it means to be an engineer. Students who practice in the program will spend time at a company for 6 working days at a time in the academic year, and they are able to map the acquired practical knowledge
into the academic syllabus. Then come to integrated RCC with the innovative practices. We have a at VNRVJT, we have a RCC, research consultation cell. So the research and consultation are very important for any institution. Research for acquisition of new knowledge, strategic inputs. So all branches of students and faculty are involved in RCC. Then database of projects, DST projects, RPS and AICT funded projects. The government are funding the various projects on the research oriented team. The research for design and development of products. External collaborative and cross-functional teams. Creation of specific domain and cross-domain knowledge centers, products and industries. Then come to consultation, design and consultation services, testing services, facilitation of department labs, IIPC, etc. Exposes to students to learn from higher platforms and opportunities to work on higher projects. Publications, funds for modernization, faculty development, research and acquisition of PhD degrees, etc. Outputs, products, patents. Out of these RCC and funding projects, faculty and students are able to produce some products and patents, some copyrights, revenues, BTech, MTech, PhD project, competitions, constructions, and partnerships. So this consultation, we can generate some revenue also. Then come to MTP and student matrixing. MTP stands for mentoring, training, and placement. So in mentoring, what is all about a mentoring? Mentoring is nothing but unlocking students' potential to improve their performance, develop their skills, and become the person they want to be. An initiative by the management to maximize student growth and development. So in a mentoring, for each faculty, some group of students are allocated. So they are monitoring the students and they are encouraging and they are they are knowing the students' interest, and then this is happening through mentoring. Next, coming to initiatives of MTP. 4 years prior to their graduation, during the first week of registration, induction program is conducted for the students to provide a support for a successful transition through create a career vision approach. Three years prior to their graduation, the students are being taken as resident shadow engineers to experience the industry. 2 years prior to graduation, the students have an opportunity for working on projects to feel as an engineer. And finally, during the graduation, the students are given an overview of higher studies, career prospects, and trained for placements. Then here one more thing is there, the matrixing. What is all about a matrixing? So in a matrixing, what we are doing is, so in a classroom at the presence of the faculty, the seniors and first year students are interacting to share the knowledge. Okay, whatever the seniors already know about the academia and then research and projects and their experience at VNRVJT, they will share. This first year students have a opportunity to interact with the students and they can know about what the already senior students are projects what they are doing. So if they are interested, they can select the they can choose a projects, and then they can also join as a fresher and then they can contribute their own. So this is the importance of the matrixing. So in order to interact with the senior student, we are creating the platform. So it helps to fresher students to quickly go through the what is happening in the institute. Then coming to autonomous, VNRVJT is an autonomous institute. In the autonomous, we have a certain flexibilities. We can choose our syllabus. We can plan our curriculum, everything on our own. We can introduce a new concepts, new subjects, new syllabus, and we can update every time. So that is the importance of autonomy. Academic reputation and previous performance in a university examination. Academic attainments of the staff. The mode of selection of students and teachers without regard to caste, creed, or social class. Physical infrastructural facilities. Institutional management and governance responsive to academic or non-academic activities. The financial resources allocation and utilization, the responsive administration structured to the views of staff and student, freedom enjoyed by the staff for pursuing higher studies and involvement in research, experimentation, innovation, and reforms. Then finally coming to uh, career opportunities for the student. So this I will give a picture of placements or higher education from last 3 years perspective. In 2018 pass outs, 19 pass outs, 20 pass outs. These are the number of placements happened 23, 37 till date in 2020. 22 students are placed. This is the higher education figures. So we have a major recruiting companies like Mahindra and Mahindra, Bosch, Hyundai, so Cyient, Tata Consultancy, E3O, and Hyundai Mobile. These are the core companies in the automobile domain. And there are some companies which are on IT side. They are also coming and recruiting the automobile engineering students. So it is a Deloitte, Capgemini, Cognizant, so Music. There are companies recruiting the students. I'll explain the scenario how the placement is happening, placement activities, and what are the opportunities for automobile career opportunities for the automobile students. Automobile students have a wide opportunities, so they can choose on a core side. They have an OEMs like automotive manufacturing companies, and they can go to some production and manufacturing companies, and they can go to some IT companies where IT companies require some coding skills. Okay, so on IT enabled services, there are certain companies like Amazon and by use their IT enabled services. So these are the wide opportunities for automobile engineering students. So we have a placement and training department at the institute level. So I'm also acting as a department placement coordinator. So the activities of the placement department from the first year onwards will identify the skills required for the student. So and we'll conduct some preliminary exams. Through that exams, we'll do some assessment where the student is lacking. So based on that, we will train. So in any organization, in any company, so during the recruitment process, they will test verbal skills, aptitude skills, analytical skills, soft skills of the students, and also coding if they are attending for the IT companies. So based on the various assessments, we will know that where the student is lacking. So if the student is lacking in aptitude, we are giving training on the aptitude, and we are conducting the assessments on how they are improving. So and we are giving some training on the coding skills like C language, Python, C++, and Java, and all. So when they most of the placements are happening beginning in fourth year. So in the during third year, we are going to conduct the campus recruitment training at the. Apart from all these things, one major training is there in the summer, third year summer. So after completion of this CRT training, students are going to attend the companies. Companies start visiting from 4.1 onwards. This is how it is happening. And students have some curiosity about what is the package and how much maximum package so far we got. So Deloitte, our students are selected in Deloitte also. So Deloitte is the company is offering highest package so far. Okay, and then there is no limit nowadays. So there are wide openings. Some companies are conducting some hackathons and coding skills and all. If you are having a coding skills and you can participate in all those kind of activities, and you can secure a job of any kind. So there is no limit at all. The only thing is, if any company coming for the recruitment, they will look at the what is the skills they require. If you are able to acquire the skills already, then you will be placed. So here the package is not at all a scenario. If you have a potential skill and all, so you can place in any company and you can get any package. So earlier what is happening, some companies are coming to college and they are recruiting. So now what is happening, mostly companies are recruiting through online platform. They are conducting some hackathons and coding contests. The students, any branch of students can participate, and then they can exhibit their talent and coding skill in the contest, and they can secure a job. So here, so that is what my idea about the package. Package, you can secure any package, but the only thing is you require a skills. And one more thing is the number of placement. There's a number of placement. Many times the companies are coming and they are conducting the interviews. They want a higher number, but they will test the student skills. If the company is coming to the college, they won't take all. So they will look at the skills what the students possesses. So if you have a skill, they will recruit any number. This is not at all a criteria. So only thing you have to undergo the training what is given at the college, and you have to practice the assessment test, and then finally you meet the industry requirement. That is one. And then apart from the placement, students are going to higher education at top universities. Here the some of the universities already our seniors or alumni are doing, just as a glimpse of universities. Professional activities of SAE. I think this part is already covered by Amjas sir. The students are participating in various professional activities. We have a Society of Automotive Engineers Society. So under this, students are participating in various national and international events, and students are developing some formula, student version of formula cards and all. I think already Amjas sir has given a brief about it. I don't want to repeat it. Then I'll conclude. Thank you. So I'll take any questions if you have. Hello, Gautami madam. Any questions from the student side?
Yeah, as of now, there are no questions, sir. We'll wait for a minute.
Yes, ma'am. Okay.
Yeah, firstly, thank you, sir, for your explanation on career vision approach.
Okay.
Yeah, students have got an idea like how they are going to spend their industrial experience time along with various activities in our college, and which could help them in visualizing their career. Thank you, sir. Yeah, so there are no questions, sir.
Okay.
So,
Thank you. Thank you.
yeah, thank you, sir.
Shall I leave, madam?
Yeah, yes, sir. Yes.
Okay.
Thank you.
Thank
Sir.
you. Okay.
I request the students to fill the feedback form, which will be sent to you. Thank you.